All right, I think we'll go ahead and get started. Welcome everybody. This is Matt Jaworski. I'm a senior technical specialist here at Autodesk. I focus on the Moldflow side of the simulation business. And welcome to the Build Your Moldflow IQ webinar titled Introduction to the Moldflow Insight API. What we're going to do is we're going to talk a little bit about the Insight application programming interface, what you can use it for, and then I'll actually give some examples at the very end. So we'll go ahead and get started. If at any time you have any questions, there's a questions section in your panel for the go-to webinar. You can type in your question in there, and periodically throughout the presentation, or definitely at the end, we'll have a section for Q&A where you can answer questions or ask questions and I'll answer them live. So let's go ahead and get started. The Autodesk Help webinar series is something that takes place typically on a Wednesday like today at 11 a.m. Eastern. I just wanted to put in a plug for the next one. There's going to be a What's New in Moldflow 2017 on April 13th at 11. So if you have time, please attend that and get signed up for that webinar as well. We have a new release coming out. There's a lot of new and exciting features that will be showcased in that. So it'd be great if you could attend so that we could show you all those new features. All the webinars are being recorded, as is this one, and they are saved on a YouTube channel. So you'll see the link to that. When this presentation is done, I will put this series of slides on a site that you can download them from, or you can go to this particular YouTube channel once the recording is done, or view any of the past webinars that are not just Moldflow related, but all of the products are available in there for any of these Build Your Simulation IQ webinar series. And if you do want to sign up for that future webinar, there's a few ways of doing that. There's the Autodesk Simulation Forums. There is the Autodesk.com/webinars website, SimHub events, they're available in there. So a lot of different ways in order to get signed up for that. So if we look at what we're going to do today, we're going to go over the API, and really the API is set up to do the two things that popped up on the screen. Hopefully save you some time on repetitive tasks, and also basically save you money by being able to utilize the software in a more streamlined way. So we're going to go over a little bit about some programming. I do have to start off with some basics just so that we're all on the same page, and also show you where some of the resources are, some scripts that already been done that you can start using right after this presentation. And we'll also go through some of the VB script editors that are available. Most of them are available for free. There's some that if you want to get it really into this, that you can pay for, because they have some extra features that you can utilize. We'll talk about scripting in Autodesk Moldflow Insight. And finally, I'll go over some examples of some scripts that have been done and show you some of the the practicality of how you can utilize this to to speed up your process. And then, as I said, at the end, we'll take some questions and answers. So the basics. If you don't know what the API is, it stands for the Application Programming Interface. It is an object linking and embedding, or OLE, I'll probably refer to it from now on, programming interface that allows Autodesk Moldflow Insight, which again, I like the acronym, so I'll refer to it as AMI for the rest of the presentation, to be automated. So things that are repetitive tasks that you do, you can utilize scripting to make it so that they're easier to be done, or things that you do over and over again, you can record yourself doing that in maybe a macro, and then modify it and play it back later for different studies and not have to do that task over and over again. So the manipulation is done through scripts, or you can actually use third-party software, and we'll talk about that in a little bit. Interesting enough, the functionality has been available since 2002 when Moldflow Plastics Insight came out with version 4.0. And just to give you a little bit of reference, that's when Lord of the Rings, the Two Towers came out, and Gollum was introduced. My Precious, all that stuff. I bring it up because that's another software that was utilized by Autodesk in order to create Gollum. So interesting enough, it's all interrelated. The additional functionality is always being added, and with the 2017 release, which I talked about as the next webinar in this series, you'll find out that there's some interesting things that are going to be in there that are related directly to this presentation. Some things that you can do with report generation and automating that and customizing report generation, and also the ability of us opening up some of our solver capabilities if you want to use maybe your own viscosity model, or you want to use your own PVT model, and so forth. We're actually opening up the solvers to be able to be utilized in the more in the API. So that's exciting, and a lot new and more features are being added with each major release. All right, we'll get off that picture. That's scaring me now. All right, so why would you use the API? I've kind of told you before, what we're really trying to do is get rid of repetitive tasks or things that you just have to do over and over again that are, quite frankly, quite boring in the software. So a lot of times you may have to build maybe a runner system. We can automate that. Maybe you have to do some plots where you may want to take a look at looking at the glass transition temperature, and then making a customized plot that just shows anything that's molten or above the glass transition temperature. We can automate that and have that be part of our process. Or maybe you want to save out a Moldflow results file for Communicator, and you're sick of right-clicking on each of the results and marking them for export on individual ones. So those are the types of things that we can help automate to make your life easier and you more productive. You can also customize the user interface with the API. You can create customized plots. You can modify plots. And again, as I said before, there is the ability in the 2016 release now to actually modify the viscosity model that's used. So if you have maybe a special viscosity model that you wanted to utilize with a particular material, you can actually go in and modify that currently in the software that you have right now. We do support third-party add-on products. It does enhance integration to things like ERP systems, CAD/CAM, Microsoft Office. You can integrate it with Excel, Word, PowerPoint, and you'll see some of those examples today. We also, have opened up some of these solvers to support university research programs, so things that they may want to try a new model with, or PhD research. They can now interact without having to go through our development team to establish a separate code that we would use inside of the software. We can also help standardize corporate protocols. Maybe there are things that are done differently in different regions in your company. You can utilize it to run a script to be kind of a standard, if you will, and it would go through and do the same process, or maybe set up the model the same way so it's oriented correctly, for instance, in the Z direction with your sprue. It also helps support industry data formats. So there's a lot of different types of formats out there. So we can help standardize on that by importing or exporting through the API. So OLE is what we utilize for this particular API, and it's really this automation client or object linking and embedding. It's needed to control the API. So by default, Insight will use Visual Basic Scripting, or VB script, to record all the scripts inside of the software. So if you use a macro, for instance, the export of that or the product of your macro is a text file that is in VB format. Now you can use other interfaces and formats. So if you like JScript, if you like VBA, which is kind of an offshoot of Visual Basic Scripting, it's more of a compiled format than an implicit format. but that can be utilized. And just so happens that Microsoft Office has that kind of fully embedded in its Office products. You can use straight VB, Visual Basic. You can use Perl, Python. Some Python in particular is one of the more popular open source codes. You can use ActiveX scripts. So there's a lot of different formats that you can use for an OLE automation client. One important note is that Autodesk really provides help and support for VBS, because we don't have experts on every single potential interface there is out there. So if you are looking for some help, it's probably best to kind of keep with the VBS. Now, continuing on that, the interface that the OLE uses is usually the first version of Synergy that you bring up. So when you launch Moldflow, the GUI that comes up is called Synergy, and that is the one that was recently executed on your computer is the one that it normally utilizes as a first pass. So if you last opened an early version of AMI, maybe you're not on 2016, maybe you did 2014 or 2015, it would utilize that. Or Lord forbid you're on an old MPI, maybe you're back in the 2.0 or we mentioned 4.0 days is when it first started. You could try to use a macro based on that, but just it's something to be aware of, that if you maybe launched an older version because you're maybe doing some comparisons or maybe looking at some old files, the OLE automation script will do the last one that you opened. And it's important to also note that if you have a macro or script that was created in an older version, there are these new features that we always modify and change. We add new functionality each release. So it goes both ways. So if you have a newer version and you utilize something that is in the newer version of the software, you can't expect it to know what that is in a version before, because it didn't exist. And if you use something in an older version of software, it may have changed its name, for instance, in a newer version of the software. So be aware of that. If you get some errors in your script, you may have to go back and take a look at what has changed in the software release or what was added if you're going backwards. Now, there is, or used to be, an issue of running multiple Synergy instances. So the first window that you brought up for Synergy was usually the one that defaulted to be the one that utilized the API. So anything from 2015 previous, this was the case. With 2016 and future versions, we said 2017 is coming out in the near future, next month. The API can now work with multiple Synergy instances, meaning that you can load multiple Synergy windows and still be able to utilize the API, no matter which version or what instance you're in. The only thing that you have to realize is at the very beginning of your script, and we'll talk about what the script looks like a little bit later on, but the first line should have this this line in it that the arrow's pointing to, which has a kind of a single quote, a %sign, and run per instance, and that is what sets it up so that you don't get the error that's on the lower right-hand side of the screen telling you that you can only utilize the API in the first window of Synergy that you opened. So that's the way that you get to kind of avoid that. And new in 2016, we added the ability to run scripts through the Synergy command line, meaning that we can now go into the command line and start a script without even opening the software. It'll do that for us automatically. So if you had a script that you may want to run silently, or you may want to just run to utilize without having the window of Synergy open, you can do something like this example down at the bottom of the screen, where you call out the synergy.exe, you tell it that you're going to be running a script with the /script, and then you give it the location of the script, which happens to be on the C drive, and this one called myscript.vbs. And when I run that, it'll open up Synergy, it'll run whatever the script has it run, and then it will close it when the script ends. There's no way right now to not open the UI, because everything's done through the Synergy interface. But in a future version, we're looking at ways to make that even silent. But for now, we don't have an ability to not open up the window. And that would be useful for if you're running something maybe on a third-party package where you want to call Synergy, but you don't necessarily want to to have it open. If we look at the API resources, you may I've showed a couple things right now. We haven't really got into what a script looks like, but you see kind of the script that would be a typical one for taking an aspect ratio and making it into a contour plot, for instance. And if you look at that script, you may be kind of scratching your head, and it's it sounds like Matt's talking English, but I look at that script and boy, that looks pretty foreign to me. And what does all those lines of code mean? Well, what I'm going to talk about for the the rest of the presentation is kind of what those lines of code mean and where you can get resources and help to explain what they are. So there's a help system that's available. There's a reference manual that's broken down into the different aspects of what each one of these things calls out. But if you think about it, all the help and reference manuals are really like a telephone book or a dictionary, if you will, that calls things in the software. And there's numeric, there's alpha, there's alphanumerics that we call out in the software that just tells the program behind the scenes what you want to do through a VB format. And what I'm going to do in the next series of slides is kind of introduce you to those resources and then finally introduce you to code, and then we're going to run some examples. So the first thing, which I utilize quite a bit, and even a lot of the experts on the Moldflow team utilize as well, is the online help. And when you hit the F1 key, or you're in the software and you hit the circle with the question mark, in the upper right-hand corner of the software interface, it's where you're going to get your help system. And once you get into the help system, you can either go under the use definitely. So we're going to talk about the Synergy interface. So if I click on that, you'll see that there's things about the OLE automation interface, macros, limitations of the API, and also there's some examples on the very end. And I find it most beneficial to go through and look at those examples, because once you get over the initial shock of this is different, this is a lot of programming, and you figure out what each one of those lines is telling you, it becomes very easy to share or grab something from somebody else to create your own script. And we'll see that there's a pretty good help system in here that has some interesting things that you could do your own customized aspect ratio plot that's more of a contour rather than the spikes or tensors that come out of it. You could show thickness within a range, export results out, maybe nodal data from temperatures or pressures at certain areas. I'll demonstrate creating a drop a little bit later for a hot drop, for a hot runner system. If you had a gas assist, you could remove the gas core out of a model and then export that out so that you had kind of a solid without the the nitrogen or whatever you used for a gas. You can extract information from the screen output file. So maybe there's some things in there that you want to show in your report, but you don't want to show the whole thing, and you're sick of cutting and pasting by looking at that. So there's some examples in there right now that you can just literally copy, throw into a text file with a VBS extension and start using today. So I would encourage you to look at those. Now there is a reference manual as well. So right next to the help button, if you will, there's a pull-down menu. And if you click on that pull-down or arrow, you'll see different aspects of that help menu. And the first one, the Synergy API reference, is one that I use, and that's really your dictionary of what all this stuff is that you maybe are doing in a macro, or you're looking at a script and you want to figure out what it's actually doing or telling you. This is how you look up the format of what each one of those commands is utilizing to call to the software itself. So for instance, if I go under one of these classes, which is maybe boundary condition, or maybe I'm looking at the job manager or layers, I can click on one of these, and if I do, I'll click on, for instance, the diagnosis manager. And in there I can look at showing thicknesses. And this gives me the code that I can do in order to tell the program to show a thickness between a range. So first I have to call out the class itself. I have to set the diagnostics manager, or whatever variable you want, to be this class, which is called a synergy.diagnosis manager. So that just sets it up so I'm utilizing this class, and then I can call that out by using the show thickness of the minimum and maximum thicknesses that I want to show. If I want to assign this diagnosis manager, this thickness manager, to a layer or not. In this case, I have it true, so it will push the elements to a new layer. And it will also only work on visible elements, which would be true, or to work on everything, whether it's visible or not on the screen, which would be false. So by looking at this, I can tell exactly what this command's doing. It's going to give me a new layer with, and also a plot of thickness of everything on my model that's between a 1 millimeter and a 2 millimeter thickness. So that's exactly what this script does right here, and this is what kind of showed me how to do it. And if I want to change it, maybe I want it from a 0.5 millimeter to a millimeter, I would just modify those two values. And there are other ways as you get better at scripting where you can actually just prompt people for what do you want the minimum to be, what do you want the maximum to be, and you can have them do that as part of your script if you want to. So again, this is just getting into it and seeing what the breakdown is of each of those different classes that we call. Now, within the class, there are things called T-codes. And T-codes are a single feature, process setting, geometry, solver parameter that's utilized to call the software. If we go and we look at the T-code reference, and we click on, again, pull-down menu in the help, the T-code reference, you'll see that there's a lot of different numbers in there, and they all stand for something. So if I click on the first one, for instance, that is utilized to determine the number of lamina across the thickness for midplane and dual domain mesh types. So by default, that's typically set to 12. I could go in and modify that so it's set to something else, 20 if I wanted to. So that really shows me what that 100 number means based on the T-code itself. Now you'll see that it's used in all these different mesh types, but also different solvers. So I have a thermoplastics solver for both midplane and dual domain. I have a resin transfer molding or a structural reaction injection molding. I have microchip, underfill, reactive. So it's used in a lot of different aspects of the solver. And you see that these are all in a T-code set. Now, a T-code set is the combination of the T-codes that's utilized to run whatever that process is. So if I choose injection molding for thermoplastics, that has a bunch of T-codes that all together will form a T-code set that the solver needs in order to run the software. Because it needs to know, for instance, how many layers through the thickness for a dual domain model that I have. It needs to know if I'm doing intermediate results or profiled results. And all those T-codes comprise the T-code set that make the solver be able to run. So if I look at, again, the same reference, but I go down farther and look at the T-code set for thermoplastics injection molding for midplane, for instance, you'll see that each one of those, have a 100, a 308 is the heat transfer coefficient. Do I want the results to dynamically update or not? All these things that you set up in the GUI or the Synergy window are behind the scenes called different numbers. And again, we can go in and modify any one of these in the T-code set, the individual T-codes, and be able to modify and run an analysis. So that may be a little bit confusing, but I'll show you a script in a little bit so that you can kind of get what I'm saying. Now, because these are text-based scripts, you'll need a text editor in order to modify the scripts. I like to use Notepad++. You can use straight old Notepad right off of the Windows OS. I like Notepad++ because it has line numbers. And if you ever are doing debugging or it tells you, hey, you have an error on line 27 character 9, you can count over 9 characters and you can see where your error is, for instance. So it makes it really easy as a text editor to modify. It also tells you, for instance, if you put that single quote in front of something, this is an area that it skips over because it's really just a text. You know, the first one, yeah, of course, that's special because that tells it that it can use multiple synergy windows. But the rest of them are comments, and I encourage you to put comments into your scripts so that people know kind of what you're doing. You know, right down here I have one where I'm looping through all studies, so I'm telling people what the script's doing from you know, line 35 down, for instance. So again, Notepad++, great program. You can also utilize VBS Edit. So there's a free version of this. There's also a paid version of this. But this allows you to actually run the scripts directly from it. It looks a lot like Notepad++ in that you can you know, take a look at, you know, your different scripts, and it also calls out things. So if you use different classes or scripting terms, they actually are broken down in a browser over here where you can actually do some searching for them. So it's a little bit more powerful of a software and allows for debugging in addition to editing. And you know, if everything I've said up to this point really sounds like you're you know, you're in the wrong webinar, there is something that allows you to get some help. Now, obviously, you can Google search. I would encourage you to look at, you know, scripts that have been done by other Moldflow people. We're in the process of creating a Dropbox, a repository of a lot of the scripts that we've done in the past. We used to have an area for this, but once we lost one of our websites, we kind of lost the history of those scripts. So, you know, look for that in the future as we get that compiled and put onto you know, more than likely the SimHub or one of the forums. We're trying to figure out which one to put it into. But when you do a search for you know, maybe one of those you know, classes or something that's inside of the script, make sure to include the word VB script, because that allows the search to know that you're looking for VBA, for instance, which is a, you know, more of a compiled format than an interpreted script. There's also a number of user guides for VB script, and the book that I have kind of in the, you know, the cute little dog looking at us. That VB script in a nutshell is a great book to also utilize and have in your library, because it talks more about the programming side rather than the Moldflow side. And we all know typically the Moldflow side, but not typically the programming side. So that'll help you out there. All right, and now, sorry, I'm trying to get a drink here. I'm going to go into scripting in AMI and go over some of that and get you a little bit more into, okay, now that you've talked about a lot of that basic, you know, stuff, how do I utilize it? How do I, you know, go into the Insight and start utilizing some of this great stuff that you're talking about? So there's two ways to automate using AMI with the API. The first one, which is probably the easiest to get into, is recording yourself doing something by utilizing the macros. And you know, these are essentially under the Tools tab. You can go in and click Record Macro, which I'll show you in the next slide, and then just start doing something, and then you stop recording and save it out. And then it will show you what you did in terms of the script. So you don't need to, you know all those and look all of those things up that we talked about. You just do what you normally do inside of Insight while being recorded, so that it can record all of those in the language that's the script. You can also run scripts through the command line. So inside of the View tab, there's the ability from the user interface to open up the command line. And I normally would utilize that when I have to, you know, give command line arguments. Remember I said before, if we're doing maybe that thickness plot, we want to prompt people for the minimum and maximum thickness that they want to display, we would have to run that script through the command line, because that's what actually allows for command line arguments to be entered. Whereas scripts that are in plain macros, if I play a macro through that, those are really for things that just go ahead and run. They don't really ask for input from the user. And that's really the difference between those. So if we look at macros, they use Visual Basic Script when they record, and when you are done recording, the macros are typically saved with a VBS extension in your default installation directory of where your projects are. So if you didn't change it, that would be under your My Documents, My AMI 2016 or 15 or whatever version of Insight that you're in. And then there's a scripts folder underneath that. So that's where they're normally stored. Now you can save it wherever you want, but that's where by default the macros are stored at. So when you're done recording and you save it out, that's where you should look for your script that you saved. Again, just to be very thorough, you'd go into the Tools tab in your ribbon. You'd click Record Macro to start. You'd do whatever you wanted in the interface, and when you're done, you'd hit Stop Recording, and then you'd save that macro out with a file name. So pretty simple process. I think everybody on the line would be able to do that, no problem, right? And then when I want to play back that macro, maybe I wanted to redo that on a different model, or maybe I did undo and I want to see it again and how quick it could be, because a lot of things that you can do in the interface may take some time. You could go into the Tools tab again and then click Play Macro, and then navigate to where the script is at, and then you could play that script. Again, if it's has some arguments in it, or maybe you modify it, then you may want to just run it through the command line rather than this Play Macro interface. You can save macros up to 10 in the interface, so that if you have ones that you always use, you may want to save those in these slots here, and you just click on Assign Macro and then which slot you want it in, and then you can utilize those. So you don't have to remember to even go in and navigate towards it. You can just click a button and it will do the macro for you. You can also run macros from Windows Explorer. So if you navigated to where those scripts are that we previously said in your My Projects directory, you could just run it from there. There are some issues that could pop up with that. So for instance, if you maybe already had a study open and you started your recording of your macro may not tell it to open up a study. So if you don't have Synergy open and a study open, it may just error out right away, because it assumed that it was at a certain starting point based on where you recorded your macro. So just keep aware of that. If you get done with this and you try a script and it doesn't work, and you're like, yeah, that Matt's crazy, this scripting is terrible. Just keep that in mind, that if you didn't start at the same point, it may not be able to run your script. And again, I keep saying it. So if you have any arguments, use the command line. I'll say it a couple times again, because that's where most people get issues, is they'll run something with command line arguments from Windows Explorer or from the Play Macro feature, and it just won't work because it doesn't have the ability to pop those windows up to give you the user inputs. So just be aware of that if you're having issues. Now, I talked about a few of these in the last slide, but again, some of the issues with macro recording are it's very specific of what you're doing and the start point that you have. So unless your start point's always the same, your behavior may be different on a different study file, for instance. And you also have to be careful when you're recording maybe a selection list. Maybe there's certain nodes that you want to get maybe a plot file for a path plot, for instance. Maybe there's a result that's only available in 3D versus dual domain or midplane that you're calling out on a model that doesn't have it because it's not the right mesh type. Or maybe you go to a different computer, or you share your script with somebody else and they don't have a Z drive on their project directory. So those are the types of things you have to just be a little bit careful of, and you can script around those, but again, the macro records very specifically. And there's also some things that aren't recorded, and you saw in the help that there's an area on the help that talks about limitations of the API, and if you go in and you look at that, you'll see that specific mouse clicks are one of the limitations that just aren't recorded. And when you select elements, nodes, those types of things, it only records the final entity. So if you had to do something in order, for instance, it may just select the entities in their totality, so at the very end what that selection list is, rather than in an order that you want. In particular with path plots, that may be an issue if you wanted to start from one area and walk to another area in a very linear fashion. If the nodes maybe are different in your selection list, because it only shows it at the very final entity selection rather than in a row. So you have to be aware of that as well. Apologize, getting another drink here. In the AMI command line, we talked about macros now and where that's at. To get to the command line, you go under the View tab, User Interface, Command Line, and then the command line will come up and look very similar to this. This allows you to use those command lines that we talked about before, allows you to provide user input or parameters that you can type in, and it also allows you to extend capabilities and utilize built-in commands that are loaded by default with the software. So that may be news to you that there's commands already in there that you can utilize today, and I'll show you that in the next slide after I talk about where they're located. So scripts are in the scripts folder, and commands are in the commands folder. So again, the same projects directory that we talked about before, but rather than scripts, it's under the commands folder. If it can't find the script or command that you have typed in, it'll look first for your local folder, being this folder, and then it will go to the default folder, which is where all those commands are located. So again, the hierarchy is it looks locally first, and then to your main commands, which are located in the default installation directory. Now, I teased you with this, but there are a lot of commands available that are by default loaded in that installation directory that you just saw. So, for instance, there's the ability to take a look at export a gas core as an STL file. So if you had a gas assist file, I could run this export gas core STL to create an STL file of what the gas core looks like. You could export some results out and send them over to Abacus. So if you had maybe some residual stresses from the warpage analysis and maybe fiber orientation, there are some scripts in there that have been around for a while that will export the mesh in addition to those residual stresses and orthotropic material properties. And you'll see a couple other. I'll actually demonstrate the roundness and the flatness one. But there's also, for those of you that are old enough to remember Moldflow View or Modeler, there's commands that you used to have to utilize back then. So it may send some people into shock to see, PO, point order, you used to have to build models manually with a command. Moldflow's come a long way since those times, but we still have those available for those people that still, either want to be nostalgic or still utilize those commands. And finally, the scripts that do not have command line arguments can be run as macros. And again, I've told you this a couple times because it is a lot of the support questions that come in. If you need to have command line arguments or ask for user input, use the command line in order to use those scripts. And again, there are limitations to the API, and I pointed to this before, but there is a section in the help that shows the limitations. When you start first programming with the API, I always try to figure out what I want to do with the script to begin with. Once I know what I want to do, I'll look for examples or pieces from other scripts that have been done before to possibly get some good hints or an outline of what's already been done, so you don't have to reinvent the wheel. It's really one of the best ways to be smart about using your time wisely. We're doing this to increase your productivity. If somebody has already done a very similar thing, why not utilize what they've done and put your own mark on it to help out, or you may find that there's already a script done that does what you want to do. So definitely use what other people have done as a starting point, because it's a lot easier. And again, you saw some examples that are available for you, and some examples that are available in the help. Use macro recording to get started off. Again, it's not perfect because it is very specific, but at least it will give you a bulk of your script that you want to do, and then you can do some modifications, by using Notepad or maybe the VBS Edit. The other thing is I really encourage you to comment. The more comments that are in your scripts, the easier it is for people to understand what you're doing, and the easier it is for people that are just starting out to see what a script looks like. And if you're trying to call or do a loop, it's nice to just comment on that in the very beginning by putting that single quote in front of your line. That would allow you to then show them that, this is what I'm doing here, this is what I'm doing there. It makes it a lot easier to see the scripts, even for people that are experts at this, because they may have done it a different way. And then finally, at the end, you test your script and then remove any errors or bugs that have happened. And again, by utilizing Notepad++ or VBS Edit, it'll show you the line of where it had an issue, or maybe you didn't call something out implicitly, a variable, and it will tell you that you have to dimension that variable, or at least define it before you utilize it. So that's a great way to start out. And I would also encourage you, when you're doing your scripts, to have this as your first set of lines here. So again, the run per instance, we know what that is. That just makes it so we can use it in multiple synergy windows. A description of what the script is, anything in syntax that you have to do. Maybe if you have to have some command line arguments, like the minimum and maximum of that thickness one example that we had. What parameters that you need to call out, any limitations, maybe it can only be utilized in an old version, when it was created. And then as you get and record a macro, this is an example of a macro that I recorded going through a communicator export, so a Moldflow results export. So maybe I'm in Insight and I go and I select fill time, temperature at flow front, so on, and then I save that out in a certain directory. This is the code that actually would do that. So the first thing that you see on here is just, real quick, it tells me that it recorded it at a certain time. It's setting it up so it's an English style keyboard. There are different style keyboards out there that aren't QWERTY based. So it just sets it so it's an English style keyboard with this command. It dimensions or declares variables that I'm going to use later. And that's a great practice to get into, so that you don't overutilize variables or have a variable that's utilized for two different things. So each one of them is unique. All this stuff right here really just sets up that OLE automation and starts synergy. So that's all you need to know about that there. You can set your units to be metric or English. That's very important for a script, because if somebody starts out by default in English and you assume that it was 1 and 2 millimeters, they're going to get quite different results when it's 1 to 2 inches. So you definitely want to make sure that you set the units for the script, and that will bypass at least the inputs that you utilize for your script itself. And then we're just initializing those classes. Again, I'm setting up a variable called Plot Manager that utilizes the Plot Manager class, and then I'm telling it to mark the result for export. If I had it false, it would unmark it. And there's another way of doing that as well. So a very simple script that shows you how to mark results for export. And if I went in and I utilized this again, it would mark each of these for export in a different study that I would do. And it would also save it out in this folder as MFR_export. So again, a nice example of a macro that I recorded, about a year, not even a year ago, that would allow you to save out an MFR file for Communicator. So we have some time here, and I wanted to go through a few examples of some scripts that have been done in the past. So let's say I have a a model, and I ran two different packing profiles with that model. And what I want to do is just compare the difference in volumetric shrinkage between those two studies. So I created a script that would allow me to open both of those studies. So let's kind of do this live and see what we can do. So if I go to Insight, I will go in and start my script. Now, my scripts are available either under my commands file, so mine are available under my C users directory, my documents, my AMI 2016 projects, and I put these in here after I recorded a macro for it, and then I made some modifications. So the first one that I'm going to utilize is called volumetric shrink difference. So I'm just going to copy that name, and then I'm going to run it through the command line. So again, the command line is available under the View User Interface command line. And once I have the command line up, I can then go ahead and run the script. Now I'm going to try it without even running a study because I know how this script is done. And I'm just going to not open a study. So I'm going to go in and run the script by just typing it in and then clicking go or hitting enter. And I've created this script so that it prompts you to, or guides you through the script itself. So it says open the first study to compare and click OK. So I'll go in, I'll open my first study, and then I'll go back to the script and I'll hit OK. Then it will go through and it'll say open the second study to compare. So I'll go ahead and do that, open my second study, and then I'll go in and I'll click OK. And then it tells me that the script is done, indicating that it's all done. So I'll just close that so you see it, and I'll close that window that I have up. And what it did is it created a new plot, a user-defined plot, that is the difference in shrinkage between the first model minus the second model, meaning that I have two separate volumetric shrinkage results that I've just calculated the difference between them. So anything that's higher means that the second model had a higher shrinkage in those areas, and anything that's lower or negative means it had a lower shrinkage in those areas. So it's a nice script where I could, rather than look at both of them at the same time and try to do the math in my head, I have a script set up that would do that math for me between two different studies. And again, something that if anybody wants, you could go in and I can modify that in Notepad, and you can kind of see, when I created that, some of the limitations, all of the code that's involved with that of opening the study, and then using what's called a customized plot after I subtract the results from shrinkage between one array and another array, displays the difference. So again, a simple script, but again, you can dissect that later and see exactly what I'm doing here. But again, as an example, that's a nice one to kind of run through. Now, if I go back to the PowerPoint, there's another one that I wanted to look at, which is called create a hot drop. Now, how many times do you maybe have to build a hot drop system, and it takes a little bit of time to do. If there's some standardized hot drops that maybe you want to record yourself building and then modify this script, this is one where you could just select an injection location and then the nodes around it that define the direction that you want to be perpendicular to. So let me show you this script. So we'll go back to Moldflow, and what I'll do is I'll just open up one of these models, and I'll just make a copy because I don't want to delete any of my results. So I'll just create a duplicate, and then I'll go ahead and open that, and then I'm just going to kind of delete the results. And I see that I have an injection point right here, and I can put this wherever I want. It really doesn't matter, but let's just assume I'm going to put this injection point here in order to have a hot drop created from it. Now, if I go in and try to utilize the command, which is called create drops, again, in my commands folder, I'm just going to copy it so I don't have to type it. Again, being smart, not lazy. And I'll go in and turn on my command line again, which I had turned off previously. If I go in and I try to utilize this, and I'm going to try to utilize it without actually doing what I know I have to do, I'm just going to go in and select create drops. It's going to try to create the drop with what I've provided it, which is I don't have any error checking in this, so it is just literally going to run until I stop it. So that's not a great thing. So there are, when you record scripts, the ability to run a loop like this that goes on, basically forever until you run out of memory. So be careful with the scripts that you utilize. There may be areas of where you can get into an issue like this where it just never comes back because you don't have error checking involved that will do that. So what I'm going to do is I'm going to kill this, and then I'm going to go back into the software, and I'm going to do it the right way because I know how to utilize this script. I'm going to go back in and open it up again. I'm going to open up the model that I did, and I'm going to turn on where that injection point is. I'll move it to where I need it to be. And the only other thing that I need for this is really to have the nodes and the triangles that are connected to it. So what I'm going to do is I'm going to select the node after I finish my injection point, and the nodes that are around it that are perpendicular to it. And I could have done half of them, but I'm just doing everything that's around it. And then I'm going to run that command. Oops. That's called create drops. And what this will do is it will build a hot runner system for me automatically based on what I already have defined in the hot drops. The only thing I would need to do at this point is just define that my injection point is now not down here anymore and move it up to the very end. But again, simple example of how you could create library of different drops that you could utilize to make your life a lot easier. Maybe it's a complex runner system, or the example that you'll see in the help system is one with multiple drops that you may want to all connect back up to a single manifold. So again, you could take a look at that and see how that is. So one of the final ones that I want to do is, if I go back, is the flatness and roundness. Now again, these are defaults. These are ones that were created by one of our developers named Dr. Franco Costa. And what this does is it allows me to look at a warp result, and I'll just open up a result here. So let me go back to the software. She'll stay in regular Insight. And I'll just open up one of these files. So let's say I'm in this directory, simple tensile bar. And maybe what I want to do is determine the flatness in warpage of one of these models. Well, I could go in and highlight an area, maybe the nodes that are in. Now, Franco was smart enough to make it so that there is error checking in this one. So if I go in and I try to use the flatness script, which is by default in your default installation directory for commands, it'll tell me right away that no nodes were selected. So he added the ability of trying to make this a little bit more bulletproof. So it's telling me that I have to select nodes of where the flatness is. So if I just go in and select some nodes on the bottom of the surface, or I could do the whole thing if I wanted to, and run flatness again, it'll go through and open the deflection plot and tell me what the flatness was before warp. It was perfectly flat, and after warp, again, it's a flat plate, so we're only getting a very minimal amount of flatness with the nodes that I have selected. Again, you could utilize that for warpage results that you have and determining how flat an area is, maybe on an edge or a wall, and that would be a useful script that you may want to take a look at. Now there is another one that may be useful as well that you could utilize, and I'm going to open up that, and maybe I have a fan blade that I'm utilizing, and I want to know how out of round an area is on the model. Now I could go in and define a center point or those types of things, but we're running out of time here. So what I want to do is just do a selection technique. So if I go under Mesh, I can select by a circular selection, and maybe I want to just go in and select based on the center of this, the inside roundness of this model. So I'm just really trying to select the inside surface itself. Now I did grab a few other ones that were not quite inside of it, but for the sake of finishing up here on time, I'll use the roundness script. So I'll go ahead and run that, and what it will do is it will open up the warpage result and determine before and after on the nodes that I selected where the center of those nodes are, what the radius of that is, both before and after the warpage takes place, shrinkage occurs, and how out of round it is, the axial concentricity. So again, a great script that if you're looking to try to see how out of round something is for a selection of nodes, great script to utilize as well. All right, because we're getting down to the end, I wanted to have time for questions. I will open up and see if there is any questions. So if you do have any questions, please type them in, and then we can, hopefully answer those. So let's see, there's a couple in here. Make this a little bigger so I can see it. All right, so the first question, looks like Paul answered some of them. Double clicking through the script, that is something that you can double click on a script and run it as well. You can look at scripts in the command line window, and there's a lot of different ways of creating the actionable item for a script. There, you saw when I was in the software, as I create scripts, there's going to be a list of them, and it's really only for that session that I'm in. So if you want to know what the other scripts are, you could type in help, for instance, and that initiates a script that has all of the scripts that I talked about from before. So if you don't know the name of roundness or flatness, maybe you typed it in just as flat, you can see what those are here, and a few other ones that are utilized in there. But again, inside of the commands file, I could have just double-clicked that as well. So there's another interesting one that I'll show you just as kind of a precursor for the webinar that was done at AU, or the class that Dave Asbury did on customized report generation. There is the ability to go in and maybe see what the range of melt temperature is for a family of materials. Maybe I want polypropylene. I can go in and run a script that will go through the entire database that we have from the standard database, and it will go in and create a Excel spreadsheet and then take the histogram out from there and show me what the range is of melt temperatures for all the materials that are polypropylene in the database, for instance. So that is, again, another script that that was done in order to to get something like that. And again, you can double-click it inside of the Windows Explorer window, or you could run it inside of the command line, whatever you want to do. Doesn't really matter. So while that's, I'm waiting for that to get through all the polypropylenes. I probably should have picked one that was a little bit smaller. I'll go on to the next question here. Access to the webinar. Again, the YouTube video will be there. I will send out a link to the slides that we have so that you can utilize those. I'll also include the scripts that I went over as well, so that you can download those from a box site that we have. Okay, and just so I can show you that histogram, there were quite a few materials, but this is about 35 materials on average are between 214 and 217 degrees for the melt temperature, for instance. So again, another script where if you want to get some information on the material database, or you don't know exactly where to start from a family perspective, there are defaults that are in the database, but it does show you the range of melt temperatures that are utilized for polypropylene, as an example. Okay. What else we have in here? Does the percent run per instance have to be commented out? Yes, it does. It's just the way that we have implemented it from a development standpoint. So as you record things, again, the first line in the script will have that little bit of comment out. It's something that we look for. So it is something that is hard-coded into the software to be that way. Guide me to use Excel VBA for multiple instances of synergy. That's something that we would probably have to talk about offline. So you can use Excel to drive things that are inside of synergy. So for instance, if you maybe had a bunch of analyses that you wanted to run where you wanted to do different melt temperatures, different processing conditions, even different materials, you could set up an Excel spreadsheet and then call that Excel spreadsheet to utilize a script from the cells to open Synergy and run those for you. There's a customer that we actually utilize that would utilize that to actually come to a result that was optimized based on the input that was exported from the analysis result. So for instance, maybe we wanted to have the least amount of deflection for a model, and rather than utilize our design of experiments, they would have a model that was created that would modify processing conditions until it was within a certain threshold from what their nominal was. That's one way to utilize it. You could utilize the scripts to interact with another program, maybe Mode Frontier, a completely separate design of experiments program where you wanted to utilize its capability and its analysis to set up your design and then have it derive the studies from that design based on those conditions that were derived from the design there. So that's also a capability that can be done. All right. Looks like we're over time now, so I'm going to go ahead and say thank you to everybody that attended. Great questions. We will send out the PowerPoints. You'll see the recording on the YouTube site. And I thank you all for your attendance and the great questions that you gave. Again, I'm Matt Jaworski. If you have any questions, you can reach out to me at matt.jaworski, Jaworski, @autodesk.com. Thank you and have a great afternoon.